these are notes 4-3. I'm going to do all notes at one time. We're going to split it up over a couple of days though in class. Okay, so first we're going to solve these. Okay, so if you think about it equal to 1, that means 1 over 1. So if it's just one fraction equal to another fraction, you can cross multiply. But the idea of what we want to do is we want to multiply by the least common denominator. So if you think about our denominators here, we're going to multiply by 2x plus 1. So if I take, I'll show it all out here at first. So if I take this times this, these two will cancel, and I'm left with just x plus 2. Now over on this side, if I take 1 over 1 times 2x plus 1, I get 2x plus 1. Okay, so we're basically just multiplying to get rid of our denominators. So when I solve this, I subtract that x over, and I subtract that 1 over, I get x equals 1. Okay, number 2. So now I note I don't just have one fraction equal to another fraction like this where I could have cross multiplied. Here I really do need to multiply to get rid of my denominator, okay? So what we want to do first is look at the denominators and see can we factor them. That doesn't factor, that doesn't factor, this does factor. This would be x plus 2 and x minus 2. Okay? Now, what can we multiply by that's going to get rid of all of my denominators? Okay, well I can multiply by an x minus 2, that will cross out this one. I can multiply by an x plus 2, that will cross out this one. And then both of these will cross out these over here. Okay, so if I'll show longhand first, and then we can kind of think about what's going on then. So if I take this times x over x minus 2, notice the x minus 2's cancel, so I'm left with x and x plus 2. Okay, my next term, if I multiply here then, I have x minus 2 and x plus 2, and I'm multiplying that by 1 over x plus 2. Notice the x plus 2's cancel, so I have 1 times x minus 2. And then here, they both will cancel out, so I'm just left with the 8. Okay, so now I have an equation that's a lot easier to solve without the fractions. So I have x squared plus 2x plus x minus 2 equals 8. Looks like I have a quadratic to solve. So x squared plus 3x, and I subtract that 8 over, it'd be negative 10. And if I factor this to solve, let's go plus 5 and minus 2. So I get x is equal to negative 5 and 2. Okay, now with all of these, I always have to look to make sure they will work. Okay, so if you think about these here, we talked about our domain being certain numbers, like all numbers except some numbers. So what numbers will not work here? Okay, well, I know 2 doesn't work, and I know negative 2 doesn't work, right? So if I put a 2 in here, I get 2 minus 2 is 0, I can't divide by 0. Negative 2 plus 2 is 0, I can't divide by 0. Okay, so do both of these work? No. This is called an extraneous solution. Okay, that's a solution. Even though we worked out perfectly fine, it's not part of our domain of answers that will work. So negative 5 is our only solution to this problem. So after you're done with these, always check them. Okay, this one here, if I factor, I have this. So what do I have to multiply by? I have to multiply by an x and an x plus 2. Okay, so when I multiply this times 1, nothing cancels out, so I just have that times that. When I multiply here, both of them cancel, so I just have the 1 left. And when I multiply here, the x over the x cancels, so I have x plus 2 times the x minus 1. Okay, so now it's just regular solving a quadratic here. X squared plus 2x. This would be x squared minus x plus 2x minus 2. So actually it's not a quadratic because if I subtract the x squared over, they cancel, so it's not a quadratic. So I'll have 2x is equal to, if I add my like terms here, I have x minus 1. Okay, if I subtract the x over, I have x equals negative 1. Okay, now will it work? Negative 1, it will work in all of those, yes. Okay, so that's my solution there. So that is how you are going to solve these. Now, same sort of idea with these inequalities. Okay, so we're going to still solve kind of the same way. So we're going to multiply by 2x plus 1. So those cancel. So I have x plus 2 is less than or equal to 2x plus 1 times 1 is 2x plus 1. And if I subtract that over, I get x. Subtract that over, I get 1. X is greater than or equal to 1. Now I drew a quick graph of this in Desmos just to kind of give us a visual here for this. So this is the equation x plus 2 over 2x plus 1 minus 1 equals or less than or equal to y. Okay, so I took that 1 over the other side to graph it. Okay, so we want to know where is this less than or equal to 0. So 0 and less would be this area right here, and that's the part that we have here, right? X has to be greater than or equal to 1. So greater than or equal to 1 would be this area right here. Okay. Now, it also just so happens, okay, so remember how we set this equal to 0, we get x is equal to negative 1/2. Okay, so this is that negative 1/2. Notice this part here is also less than or equal to 0 as well, right? Okay, and we have that asymptote here at, since the degrees are the same, at 1/2. Okay, so well, yeah, actually it's different than that because of there. But anyway, we have this asymptote coming across here. So this part is also less than or equal to 0. So our answers is actually going to be negative infinity to negative 1/2, and then also from 1 to infinity. Also, this is or equal to, so we're going to put a or equal to there bracket. Okay, number 5. If I cross multiply, I have negative 10, or if I multiply both sides by x minus 5 and x minus 6, I have negative 10 times x minus 6 because the x minus 5's cancel. And I have negative 11 times x minus 6's cancel, x minus 5. Okay, if I solve this, negative 10x plus 60, negative 11x plus 55, add your 11x over, subtract your 60 over. Okay, I get this equation. Now, these, we always want to get a graph of them too. So if we look at Desmos, or let's think about what the graph's going to look like. This is how I would graph it. I would take this and I would take this over. So negative 10 over x minus 5 plus 11 over x minus 6 equals our y, or equals 0. Okay, so when you look at that graph, I know my at 5 and at 6 are going to be my asymptotes. Okay, and the graphs look like this. And it comes down like this here, and down there eventually. You'll see that down there too. Okay, so where it's equal to 0 would be here at negative 5, right? So what we need to do is find where is it. Okay, so basically I want to know this equation here, right? Where is it greater than or equal to 0? So greater than or equal to 0 would be right here, and also be right here. Okay. So my solution would be negative 5 to, what was this? This was 5 and this was 6, right? So my solution would be from negative 5 to 5. And then from 6 through infinity. So you really kind of need to get a graph here because of these asymptotes. Okay. Another way to think about that is this. You can kind of make a little chart. So I know there's a sign change possible here at negative 5. I know there's also another sign change at 5 and another sign change at 6 due to the asymptotes. Okay, So you could take a number that's less than -5, take the number less than -5, like -10, plug it in here, see if this side is greater than this side, which it is not. Take something between -5 and 5, like 0. 0 minus 5, right? And 0 minus 6 would be pretty easy, and that works. Okay, those numbers, this side is greater than this side. If you take some number between 5 and 6, like 5.5, it's going to give you a y-intercept, right? This side is not going to work. Take a number greater than 6, like 10. This side is going to be greater than this side, so it'll work. So you can also think of it that way as you go through it. Okay, if you think about solving this one algebraically, we're going to multiply both sides by x squared plus 4x minus 5. So here these will cancel. So you have 2x to the third minus 2x squared minus 12x. And that times 0 is still 0. Okay, when solving this, we can factor out a 2x. And then factor this x minus 3x plus 2. And then we get x is equal to 0, 3, and -2. Okay. So we can use Desmos, or think about it here. I know it's going to have x-intercepts at 0, and at 3, and -2. And if I think about the other sign changes that are possible here, okay, if I set this, this would be x plus 5 and x minus 1. So I have asymptotes at -5 and at +1. Okay, and the graph is going to look like this. This part here will come down and go through here and then up through here and go to the asymptotes there. And this part here will come up from here and go up through there. And this other part over here will come up and go like this. So there's actually an oblique asymptote right here as well that this goes across. Okay, so we want to know, where is this graph less than 0? Okay, so one way is from looking at the graph, I know that all these points are less than 0. So I know from -infinity up until, what was this, -5, right? Up until -5. I know that all is less than 0. Here it's above 0. Here it's equal to and then less than. Okay, so from -2 to 0. It's also less. Okay, so this part's less. This part's less. Also this part is less. Okay, so from that's at 1. Okay, so from 1 to 3. Okay, so also from 1 to 3 would also be where it's less than 0. Next problem. Okay, if you remember back, negative exponents means 1 divided by it, so this is the same as y equals 7 over x to the 4th minus 8 over negative, means x squared on the bottom plus 1. Okay, we want to know where this is equal to 0, so we want to solve this. So I'm going to multiply by x to the 4th. X to the 4th times 0 is 0. X to the 4th cancels, so I have the 7. X to the 4th over x squared is 8x squared. And then I have plus x to the 4th. Okay. Now we want to factor this. Usually we see it the other way around, so I'll just flip it around real quick. X to the 4th minus 8x squared plus 7. So if I factor x squared and x squared, it looks like it's minus 7 and minus 1. If I set them both equal to 0, so I get add 7 over, take the plus or minus in the square root, and same thing there, I get plus or minus 1. Okay, so there's my solutions. Now if we look at the graph of this, if you graph it on Desmos, it looks something like this. And the same thing from the other side. Okay, so we have the square root of 7 is like 2.6 or whatever right here. and negative square root of 7's there. And then we have 1 and 1 right there. Okay, and we have asymptote at 0. Okay, so this would get closer and closer to 0 as it goes up. Okay, now we want to know for this one, where is our graph less than or equal to 0? So less than or equal to 0 would be this part right here. So between negative square root of 7 and negative 1, and it's or equal to. And also here, between 1 and the square root of 7. For greater than or equal to 0, that'd be this part. So that goes from negative infinity all the way through negative square root of 7. And it's or equal to here. And then it goes less, and then above again here. So square root from 1. And then right here at 0, there's an asymptote, right? So till 0. And not including 0 because that's an asymptote. And then from 0 to 1. Okay, so this part here, and then it goes below, and then it goes above again from the square root of 7 to infinity. Okay, it's number 8. A manufacturer wants to construct a cylinder aluminum can with a volume of 2,000 centimeters cubed, which is like a 2 liter. What radius and height will minimize the surface area, the amount of aluminum being used, surface area, and what would the volume be? Okay, so first of all, surface area is equal of a can is 2 pi, we'll say r is our radius, our x is our radius, okay, rh plus 2 pi x squared, 2 pi r squared. So pi r squared is one base of the can, and then another base of the can makes 2 of them. And then that's your lateral area around the outside. Okay, our volume is pi r squared or x squared h. Okay. Okay, let's solve for the h here. Okay, and we know our volume is going to be 2,000, so we'll put the 2,000 in there. We want where the volume to be. So if I solve for the h, my h is going to equal 2,000, and I can divide by these two, right? Divided by pi x squared. Okay, now I can take this and I can plug this in right here. So I have 2 times pi times x times 2,000 over pi x squared plus 2 pi x squared. If I multiply these together, that is 4,000. Pi cancels, one of the x cancels over x plus 2 pi x squared. Okay, and if I multiply this one here, the top and the bottom, by an x over x is 1, right? So it won't change it. And then I can add those like terms together. I get 4,000 plus 2 pi x to the third, all divided by a common denominator of x. So this is our volume. We basically want to know where that volume is going to be, kind of the minimum, right? Okay. So if you would graph this, the graph would look something like this, and that minimum point there is the point 6.83ish, and 878.76. Okay, so that's the minimum there. So the radius, or the x, should equal about 6.83, and the height, okay, the height, I can plug that back in here. So 2,000 divided by pi times your x squared should be about 13.65 centimeters. Okay, and that leads to minimum surface area would be about 878.76, which is what we have right there. Okay, So that gives us that volume that we need. Okay, last section here in this part, 4.3, is variation. You've talked about these back in Algebra 2, I believe, or at least in Algebra 1 you did these first two. Okay, direct variation was y is equal to k times x. Inverse variation was y is equal to k divided by x. And a joint variation was y is equal to k times x times z. Okay, they're jointly related there. Okay, k is called the constant of variation. Okay, so if we do an example here, the intensity of light, I, is inversely proportional. Okay, so we're going to do this. I is inversely proportional, so inversely goes on the bottom, the second power of the distance, so distance squared. Okay, so we have our equation to use here. So now we're going to take some numbers. So 3 meters has an intensity of 0.88. So we're going to take those numbers and put them in here. So the intensity is 0.88 when our distance is 3. Okay, so now I can solve for that k. 3 squared is 9, and if I multiply both sides by 9, I get a k is 7.92. Okay, now I can use this information to determine the intensity at 2 meters. So our intensity is going to equal our k, which is 7.92, divided by 2 meters. So 7.92 divided by 2 squared is 4. Gives me an intensity of 1.98. Okay, number 10. The volume of wood okay, so when they cut down a tree, the amount of wood it gives you would vary jointly. Okay, so the volume varies jointly with the height to that power and that power of its diameter. Okay, so depending on how tall it is and how wide it is, that's how much wood, right? The volume of the wood that is there for the tree. Okay, so to those powers, there's our equation. Now if we plug something in, that's 13.8. So if we have a tree, okay, that's our diameter, and a 64-inch height, that's our height, and it gives us this volume. So let's plug all those numbers in. So 25.14 is equal to my k, and height was 64 to the 1.12, and 13.8 to the 1.98. Okay, so now I got to work this out. Basically, you can take these and use Desmos and multiply those together, and then divide it over, and you get a k that is equal to about 0.00132. Okay, now last one. Estimate the volume of wood with a diameter of 11 and a height of 47. So I know my volume is going to equal our k, which we said was 0.00132, times the height, which we said was 47, to the 1.12, and diameter was 11, raised to the 1.98. Okay, you work all this out, put it in Desmos. There's about 11.4 cubic feet. Okay, that's how much wood that tree would produce. Okay, and the last one, for those of you that are into photography, I don't know a whole lot about this, but luminance, L, varies directly with the square of the f-stop. You can adjust your f-stop when you're doing cameras. I'm not really good at that stuff. Miss Walton would be good with that. Inversely with the product of the film ASA number and the shutter speed. Okay, so we have this equation. it's, okay, and it gives us the k is 25, so I can put the k in there right away. Directly with the f-stop, square the f-stop, so f-stop squared. And inversely, so inversely is going to be on the bottom, with the product of the ASA number, and the shutter speed, which was t. Okay, so there's our equation. Then we could, if we want to know if they give us some variables, we could plug them in and find the other variables.